In this video, we will examine the mechanism of formation of a dinucleotide. I will be pointing with different color markers as I'm discussing the steps of this dinucleotide formation from the two mononucleotides. And as you can see, I'm going to circle the first mononucleotide, the deoxythymine triphosphate in red, that's it, and the deoxyadenosine triphosphate in red right here. So each mononucleotide has already an old ester bond, and I'm going to circle it, okay, right here. I have, for simplicity reasons, added the hydroxyl group to each one of the three phosphorus atoms, okay, and I did the same right here. Normally at pH 7, there is between 1.4 and 2 negative charges. What we are going to do, we will be observing the formation of an ester bond between this oxygen right here, I'm going to color it in green, and this phosphorus atom right here. So in order for me to be able to refer to the phosphorus atoms with ease, I'm going to label this one alpha, this one beta, and this one gamma, okay? You can see that each mononucleotide has a deoxyribose sugar with carbons 1, 2, 3, 4, and 5, and the same thing down here, 1, 2, 3, 4, and 5. Okay, of course the second carbon has a oxygen missing here and an oxygen missing here in DNA, and you have the different bases. You have thymine right here connected to carbon 1 and adenine connected to this carbon 1. So the next step, it's an intermediate step. During the intermediate step, there is a neutrophilic attack, and the attack is from this hydroxyl group up here onto the alpha phosphate below that I'm circling in green right now. So there is an attack. What happens? A pair of electrons, I'm going to draw it with a blue marker, a pair of electrons are going to be moved from this oxygen onto the alpha phosphorus atom. And at the same time, a pair of electrons, it used to be a double bond here, a pair of electrons will be moving onto the oxygen. Therefore, this oxygen will be negatively charged and this oxygen will be positively charged. So we have a loss of a double bond. In the next step, I'm going to make it in red. There will be a reformation of a double bond right here, but this pyrophosphate is going to get lost. In the last step, what's going to happen, we're going to have a protonation of the pyrophosphate and a deprotonation. As you can see, this hydrogen gets lost. Deprotonation of the old hydroxyl group. So let's look at each step one at a time. During the intermediate step, okay, I'm going to put intermediate step. You will notice, okay, you will notice that a pair of electrons, okay, are going to be moving to the alpha phosphorus atom, and at the same time, a pair of electrons from the double bond between the alpha phosphorus atom and the oxygen will be moving right here. So let me complete my drawing so everything makes sense. Okay, so these have one up here, a hydroxyl group below like I showed you before, and there's an oxygen here, and I'm gonna just put a thymine here to make things easier, and a hydroxyl group here, and this one is also connected to another deoxyribose, but this carbon 1 has adenine instead of thymine, okay? And right here we have the future pyrophosphate, not yet, okay? So I'm quickly sketching it for you. So I'm gonna color it in red. A pair of electrons have moved from the hydroxyl group, so this is called the neutrophilic attack, okay? And a pair of electrons from the double bond are going to move here. So therefore, because this one has lost a pair of electrons, it becomes positively charged. This one becomes negatively charged. At this point, if you look at the alpha phosphorus atom, it has 1, okay, 1, 2, 3, 4, 5, okay, and it would have 6, okay, but it has only 5 bonds because this one disappeared as the electron moved up to the oxygen. So it has 5 simple bonds. In the next step, which I will show you in a second, we're going to have the reformation, okay, so reformation of the double bond and elimination of the pyrophosphate, okay. So the phosphorus, the alpha phosphorus, is going to reform the double bond, okay, and I'm going to quickly sketch that. This one has an adenine, and the double bond got reformed. It has an ester bond up here with the oxygen. The hydrogen is right here, and has a hydroxyl group right here. So there is a reformation of the double bond, but immediately there is also an elimination of the pyrophosphate, okay? So here is my pyrophosphate real quick. I'm going to circle the pyrophosphate in red. The pyrophosphate gets lost. The double bond is reformed, so let's count the bonds. 1, 2, 3 is the new ester bond, 4 and 5, okay? And I'm going to complete my drawing here. So we have this connected to the phosphorus atom above. Okay, OH, double. Okay, and here we have the hydroxyl group, another hydroxyl group, and this one is right here. But we have a thymine connected to the first carbon, hydroxyl group here, hydrogen and oxygen. Okay, so here we have the reformation. I'm going to point with the blue arrow, the reformation of the double bond and the loss of the PPI. Okay, and the next step, what's going to happen during the next step? During the next step, we're going to get deprotonation of what? Deprotonation of the oxygen in the hydroxyl group, okay, of oxygen in hydroxyl group, and protonation of the pyrophosphate. Okay, so if you recall real quick, one last time, here we have the upper mononucleotide. And below we have the lower mononucleotide, but now they're already a dinucleotide. Okay, so this phosphorus atom already created a double bond. It has an OH down here, and it has the old ester bond right here. There is an adenine here and oxygen. So there is a deprotonation. I'm going to color it in red. Deprotonation of this proton is going to be leaving of the old hydroxyl group, and there will be a protonation of the PPI. Okay, and there you go, the pyrophosphate leaves, and a dinucleotide is formed. I'm going to circle the dinucleotide in green right here, and I'm going to circle the pyrophosphate in purple right here. So this is the pyrophosphate, this is the dinucleotide, and you will see this ester formation. Okay, so we have a phosphodiester. Dinucleotide formation not only in DNA but also in RNA and other oligonucleotides.